An MCB is an electrical safety device designed to automatically shut off the flow of electricity when it detects overload or short circuit conditions. It protects electrical circuits and devices from damage and reduces the risk of fires or electrical hazards. In this video, we explore some of the essential tests conducted on MCBs at BIS laboratories as per IS 60898 Part 1. These tests ensure the safety, reliability, and performance of the devices. Marking and general test. This test ensures that all required information such as the manufacturer's name, product type, ratings, and compliance with IS 60898 is correctly marked on the MCB. It also includes verifying the general construction of the device for compliance with the standard. Indelibility of marking. This test is made by rubbing the marking by hand for 15 seconds with a piece of cotton soaked with water, and again for 15 seconds with a piece of cotton soaked with aliphatic solvent hexane, to ensure they remain legible and do not fade, even under operational stress. Tripping test. The tripping test of MCBs as per IS 60898 ensures their reliability under overload and short circuit conditions. In the overload test, a current of 1.13 times the rated current and is applied for 1 hour for MCBs up to 63A and 2 hours for those above 63A, during which the MCB must not trip. Next, the current is increased to 1.45 inches, where the MCB must trip within the same respective time limits. After that, the instantaneous tripping test applies 2.55 inches, requiring MCBs up to 32 amps to trip between 1 to 60 seconds and those above 32 amps to trip within 1 to 120 seconds. These tests confirm the MCB's ability to protect circuits safely and effectively. Resistance to humidity. In this test, the MCB is exposed to high humidity levels to assess its performance and insulation properties under adverse environmental conditions. The humidity treatment is carried out in a humidity cabinet containing air with a relative humidity maintained between 91% and 95%. And the temperature of the air in which the sample is placed is maintained at any convenient value between 20 degrees Celsius and 30 degrees Celsius for 48 hours. Insulation resistance and dielectric strength test. First, we measure the insulation resistance between auxiliary circuits connected to each other and the frame, as well as between isolated parts of the auxiliary circuits. A test voltage of approximately 500 volts DC is applied for 1 minute. The insulation resistance must be no less than 2 megaohms. Next, we verify dielectric strength. In this test, we apply a high voltage to check the strength of the insulation. The voltage is increased gradually and held for 1 minute between specific parts of the circuit. If the circuit is rated between 110 to 250 volts, we apply 2 kilovolts for testing. No sparks or damage should happen during the test. Temperature rise test. The temperature rise test ensures that circuit breaker components remain within safe temperature limits during operation. The test is conducted for a duration of 4 hours under normal load conditions. The temperature rises of parts such as external terminals and operating mechanisms is measured and should not exceed specified limits, like 60 degrees Celsius for terminals and 40 degrees Celsius for operating mechanisms. This test verifies that the circuit breaker operates safely without causing damage or overheating surrounding parts. Glow wire test. In this test, a heated glow wire at 960 degrees Celsius plus or minus 15 degrees Celsius is applied to the circuit breaker's insulating parts for 30 seconds. After removal, any flames or glowing must self-extinguish within 30 seconds. The test ensures no ignition of tissue paper or scorching of a pine wood board, confirming the material's safety and fire resistance. Conclusion: each of these tests ensures that the MCB meets the safety and performance standards outlined in IS 60898-12015.